Determine whether the pair of lines are parallel, perpendicular, or neither. We have two lines given. The first line is y equals 1 half x minus 5. The second line is y equals 2x plus 4. In our previous videos, we've looked at graphing equations of lines that are in slope-intercept form, the y equals mx plus b form. This first line has a slope of 1 half and a y-intercept of negative 5. So we go to negative 5 on the y-axis, plot a point, and then because the slope is positive 1 half, if we go up 1, right 2, up 1, right 2, you can see that your line, if you were to connect a series of dots, would be represented by this magenta line. Again, plot your y-intercept first, then use your slope as directions to another point. When you connect, you've got the graph of your line. Line number 2 has a y-intercept of 4, so you go to the point 0, 4, plot a point. A slope of 2, which is also 2 over 1, tells us that if we go up 2 over 1, that's another point that our line goes through. Up 2 over 1, that gives you a series of dots that connect. So this blue line is the graph of y equals 2x plus 4. Now this is a case of neither parallel nor perpendicular. They're not parallel because the slopes are different. One slope is a half, the other line has a slope of 2. So they're not parallel. They're not perpendicular either. Visually, these lines don't intersect at a 90-degree angle. That's why I like to graph lines, is because visually you can tell they're not parallel. Because they don't intersect at a 90-degree angle, they're not perpendicular either. Now, mathematically, another way to check for perpendicular is you multiply the slopes of your lines, 1 half times 2. If the product is negative 1, then you have perpendicular lines. If the product is not negative 1, then you don't have perpendicular lines. So this is a case of neither. These two lines are neither parallel nor perpendicular. Same type of problem, we're just switching up our two lines. Our first line is y equals negative 4 ninths x minus 3. That line has a slope of negative 4 ninths and a y-intercept of negative 3. Line 2 has a slope of 9 fourths and a y-intercept of 1. Y equals 9x plus, y equals 9 fourths x plus 1. To graph the first line, we plot a point at 0, negative 3. Our slope negative 4 ninths, if we go down 4 over 9, that gives us another point. Connect those 2 points, and you've got the line y equals negative 4 ninths x minus 3. For the other line, plot a point at 0, 1. The slope is positive 9 fourths, so if we go up 9 over 4, that's a second location to connect, and this blue line is the graph of the second function. Just by visualizing the slopes in the equations, negative 4 ninths is not equal to 9 fourths, so there's no way these are parallel. Plus, you can just look at your two lines and you can tell they're not parallel. They are, in fact, perpendicular. That means they intersect at a 90-degree angle. If you take the first line's slope and multiply it by the second line's slope, you get negative 1 as the result, and that's how you can test for perpendicular. Another one is a quick visual. If you take the first slope, flip it over, and change the sign, and you get the second slope, that's a quick way to determine perpendicular as well. Find the equations of lines that pass through the given point and are parallel to and perpendicular to the given line. The given line is x plus y equals 6. One way you can graph that is to calculate intercepts. If you let y be 0 and solve for x, you get x equals 6. That's the x-intercept of that line. Now, if you let x be 0 and you solve for y, you'll get y equals 6. Plot that point, connect those two dots, and this black line represents the line it's given, x plus y equals 6. Now, the point that's given is negative 4, 1, so I'm just going to plot that point, and it's right here. We're first asked to find the equation of a line that's parallel to the one given. So we need a line that's parallel, also meaning it has the same slope as the original. If we isolate y, we get y equals negative x plus 6. So the slope of the line given is negative 1, and its y-intercept is 6. That means the parallel line to it has to have the same slope. If you go to the point negative 4, 1, and you maintain the same slope, which is negative 1, that's down 1, right 1, down 1, right 1. When you connect those dots, you get this purple graph. Following it very closely, we know the slope is negative 1, so we have y equals negative 1x, but it passes exactly through the y-axis at negative 3, and that lets us write minus 3 as the constant on the end. Now, in order to be perpendicular, we need a slope that, when multiplied by negative 1, gives us negative 1 as the answer. Because remember, for perpendicular, when you multiply the line's slopes, the product has to be negative 1. So what slope times negative 1 gives you negative 1? Positive 1. So that's the perpendicular slope we're after. Go back to the point that's given, negative 4, 1. Run a slope of positive 1, up 1 over 1, repeatedly. When you connect those, you get this blue line. Counting it slow and carefully, the blue line, the one that's perpendicular, has a y-intercept of positive 5 and a slope of positive 1, so its equation is y equals 1x plus 5. The blue line is perpendicular to the black line. That means it intersects at a 90-degree angle. It also passes through the point we were given. The magenta line or purple line is parallel to the black line, and it also passes through the point that they specified. A different example, same type of problem. They give us the line y equals 3 halves x minus 4. Let's plot that line. It has a y-intercept of negative 4. A slope of positive 3 halves. So from negative 4, if we count up 3 over 2, connect those dots, we get this black line. That represents the original linear equation given. Now, the point they want us to have a parallel and perpendicular line go through is negative 2, 4. So if we plot negative 2, 4, that's the point that we're supposed to go through. First, we have to be parallel. Now this line, remember, had a slope of positive 3 halves. So if we go to the point negative 2, 4, and we go up 3 over 2, that puts us at 6, 7, I miscounted. It puts us at 7 on the y-axis. So this magenta or purple line, we have y equals 3 halves x, because it has to have a matching slope in order to be parallel. And it does cross the y-axis at positive 7, so y equals 3 halves x plus 7. Now it's going to be a little harder on this one that's perpendicular, that crosses at a 90, not because the slope's hard to find, but because when you multiply this by negative 2/3, that's how you get a product of negative 1. So let me say that another way. This line has a slope of 3 halves. If you flip the fraction and change the sign, you get negative 2/3. So this is going to be the slope we need for perpendicular. Now, if you go to this point that they give us and you count down 2, right 3, down 2, right 3, and you connect, you get this blue line. Now, visually, you can tell it's perpendicular, but on the y-axis, it does not cleanly pass through at a whole number, and that causes a problem because we still need to know what value it crosses the y-axis so we can get the b part of y equals mx plus b. Now, from previous videos, we know that if we have a slope and a point, we can write the equation of a line. Y minus the y coordinate, y minus 4, is equal to the slope required. In order to be perpendicular, we have to use a negative 2/3. That's m, parentheses, x minus the x coordinate, negative 2. Two negatives back to backs, change to a plus sign. Distribute your negative 2/3, that's negative 2/3 x minus 4/3. To solve for y, we add 4 to both sides. This is 4, it's just written as 12/3 so that I could add it and we have a common denominator. Negative 4 plus 12, that's 8/3, and this is our function's equation. Y equals negative 2/3 x plus 8/3. 8/3 is 2 and 2/3, and that is very reasonable based on our graph. So this one turned out to be pretty tedious.